Hello everyone. In this video, we're going to talk about how to create a service and then use it to control turtlesim. So service is one of the most important forms of communication in ROS2 where we could keep it running and then command whatever we need to the service as a request, and then that particular node receives it, works on it, and then responds back. So that's how a service model works. And we would be writing a service in C++ to control turtlesim. Let's dive deep into that. To create this package inside this workspace, we go to the source folder, and then once we go there, we use the ROS2 package create command with the following dependencies. So once we create the package, we can see the name is service package, and inside it there is the source and then CMake package XML, and then we create this launch file to add the we create this directory called launch, and we add the launch file in it. So to create the C++ code to do this service, that is to receive either true or false, and based on that move the turtles in. This is the code we write. So we start with including all the necessary header files, which is RCL standard service, setbull, and then geometry messages, twist message. And then we include memory to use shared pointers, and then we create alias names so that it makes it more readable. Uh, so we start again by defining a class called server node, and then we also inherit this RCL and then we do the initialization where we initialize this class and also the subclass, giving it the name service moving, and then also this variable we set it as false. So like how we define a publisher, this is the same way we do it for the service too. It's like this create service and the type of service what we're using here, we're using the set pull, and then we define the name of the service and we bind it to a callback function, and here we are using the moving callback. This is what happens whenever you get a request for the service, and then we include we reference this class, and then we have the two namespaces here. One is for request, another one is for response. And similarly, we also have a publisher in this case because we want to publish the velocity to the turtle sim based on what service request we are getting. And here we're using a timer too because we want the turtle sim to be moving regardless of a request. We don't want to constantly give a request to keep the turtle sim moving. Um, and we want it to be in such a way that once you trigger it, it just keeps moving, and then again you trigger it to stop, and then it just stops. So the timer command will constantly publish that message, and so that it'll keep running. um, so next we declare all the variables and functions, that is the service, the publisher, timer. We can see that they're all defined as shared pointer, and they are type. We use the current message which is of twist, and then we use this bool moving, which you'll see when it's used. So this is the callback function for the service, and you can see this is for the request and this is for the response, and both are from setbull. And here we have like if request data. So the setbull basically has request and response. The request is a boolean, and the response has two different variables in it. One is the how successful it was, that is the response success, and then the other one is the message response message. So here you can see that if we get like any request which is like true, suppose if we get it true, then we set some velocity and then in both linear x and angular z, and we set the moving to be true. And once all of this is done, we also set that response is success because we have reacted to the request, and then so we set the response success to be true, and also response message that whatever we're trying to do here, we are turning the turtle sim when the request is true. If the request is false, then we set the velocities in both linear x and angular z to be 0, and also we set moving equals false. And similarly, we set the response to, because we have reacted to it, we set it true, and then we also set the response message that it's time to stop the turtle, because here this is the case when it's for false, and the request is false. And this void publish velocity, which is a callback function of this timer. So every 100 milliseconds, this publish velocity function will be called. So this function, you can see that it's a void, and then you can see based on this boolean variable, we either publish or not publish. So when we set it as true here, that is when the request is true, it'll keep constantly publishing this value over there. So we use publisher publish current message. So this will publish to the to this topic, which is turtle1 command velocity, which is the topic which makes the turtle sim move. And once that's done, then we have the entire class defined. And now we can define the main class to trigger this class which we defined above. So we initialize the ROS2 client library, we create an instance of the class and run it continuously by using the spin. And then we also give a command that when you want to shut it down, it just completely closes the ROS2 client library. So this is it for writing a simple service node, so that based on what it receives, whether it's true or false, the turtle sim reacts accordingly. And with regards to the CMake list, what we do is we add the executables, we add the install, and then we also add install the launch. So we need to have the name of this executable over here, and then we need to have the launch file which is over here also in the directory install directory. And then here we give the command to make it into an executable. So this will be the name of the executable, this will be the path of where you wrote the C++ code, and then here we write the name of this executable and define all the dependencies here. um, for package XML, it's the same. Make sure that all the dependencies, the headers which you included are here. Um, and once all of these things are done, you just create a launch file the same way you have done for the publisher in my previous videos. So you include the header files, and then you use generate launch description, and then you return this launch description with by defining a node, and then the name of the package, the name of the executable which you saw in the CMake list, and then output a screen. So once this is done, you have successfully created a package which would behave as a server to control your tourism. So in order to simulate it, so first we build it, call count build. Once it's completely done, once this package is done building, then we do source install setup.bash, and then we launch this service package. So ROS2 launch, name of the package and name of the node. Once that is done, we have this running, that service is running, and then now we just launch the turtle sim nodes to see whether things are working. So in order to call it, we do ROS2 service call, and then we give the name of the service, move clockwise, and then we define the type of the service, and then we give data colon, and then we give whether it's true. I can see it's moving, and now if we hit pause, it just stops. And then again, if you want to move, we just give true, and it just starts moving. So this is how we successfully implemented a service for this turtle sim. So that's how you create the service and control a turtle sim. And this can be used for any other application you're working with to create a service and then use it however you want. Only thing is that the type of service might change and how you publish the messages might change, but the entire concept is this. Thank you for watching, and follow for weekly robotics related content.